Here we are, guys, Unit 5, which is about radicals. Today we're going to talk about square roots and their graph. So our objective for today is that students will be able to graph square root functions and determine their domain and range. So the first thing that we need to just recall is that square roots are the natural inverses of squaring. In other words, finding numbers that when you square it would give you an input. So remember we talked about something like y square. How do we get rid of that square? We need to take the square root, which cancels both of those off. So we're giving two functions. F of x is equal to the square root of x, and g of x is the square root of x plus 3 minus 2. Now be careful when you're entering this into the calculator. Only the x plus 3 is under the radical sign, and then minus 2 is outside. So graph this with or without using the calculator. You can just, all you go to is your home, and then you go to your graph. So go to home on the calculator, and then you go to graph, and you want to enter these two functions. This is my first function, this is my second function. When you enter that, you should have something that looks like this, which is what you're going to sketch. The square root of x looks something like here, and then the square root of x plus 3 minus 2 is my second function. So it says, notice that when you do your graph to set your axis, it's negative 10 to a certain x value that's not in the domain. Just be careful when you set that up. So here we're going to talk about our follow-up question, which is, what is your domain and your range using set builder? Set builder is when you write x such that x is equal to blah 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 blah. Your domain, we know it's my x, and my range is my y. So looking at this graph right here, my f of x graph, I can see that the domain is x such that x is greater than or equal to 0. It's greater than or equal to 0 because it starts at the origin and it goes on and on and on forever. Now, what is my range for this section? So my range is my y value. I'm going to be looking up, down, my vertical line here. So it starts at 0, and then notice again, it goes up and up and up, and the arrow means it goes on forever. So my range is going to be y such that y is greater than or equal to 0 as well. This does not always happen, and we'll see that in the second example. It's not always going to be the same thing. Let's look at this one here. Your g of x is equal to the square root of x plus 3 minus 2. Your domain is my x value. So I'm going to be looking at my x values. This is my farthest to the left, and it goes on forever. What's this point right here? Negative 3. Perfect. This is negative 3. So my domain is going to be x such that x is greater than or equal to negative 3. Greater than or equal because this circle is shaded. My range now, I know it's going to be y such that y is, what is my range? It starts at negative 2 and then it keeps on going. So it's going to be greater than or equal to negative 2. Okay? Now moving to the second example. So this is how it shows on the regions. Which of the following equation will represent this graph? All we have to do, guys, is plug this into your calculator. If you're having an issue plugging this in a calculator, see me. You need to know how to plug these in the calculator. So by just looking at this and plugging in all these answer choices in the calculator, you will see this graph represents choice number 1. Remember, you don't know how to enter this in the calculator? See me, please. Alrighty, moving along. Here, as we've seen in the first exercises, the domain of square root functions are oftentimes limited due to the fact that square root of negative numbers do not exist. So this is what our key thing, square root of negative number does not exist, meaning if I take the square root of negative 7, you will see it says error on your calculator or undefined, something like that. So, which of the following value of x does not, and that's my keyword, does not lie in the domain? Y equals square root of x minus 5. So this is one of those questions where all you have to do is plug in the answer choice into x and then check your calculator. One of them will be undefined. So the first one I want to look at is choice number 1. So if x is 6, I'm going to get the square root of 6 minus 5, which is the square root of 1, and that's 1. This is 1, so 1 is out. 2 says the square root of 2 minus 5, which is the square root of negative 3, and this does not exist on the calculator. Does not exist. So which of the following does not lie on that domain would be choice 2. If I was to plug in 5, I would get 5 take away 5, which is the square root of 0, which works. And if I was to plug in 7, I will get 7 minus 5, which is the square root of 2, and it will give me some answers. Exercise 4, it says determine the domain of the following. Express your answer in interval notation. Interval notation is when we have something, I don't know, let's say 3 comma 15 included. So the way we do this, we take what's under my radical sign and I make it greater than or equal to 0 because I know that the square root cannot be less than 0. Anything that less than 0, like you see here, negative 3 does not exist. So the first one we have is x plus 2 is greater than or equal to 0. And I would solve for x minus 2 on both sides. X is greater than or equal to negative 2. So interval notation would be negative 2 would be included, and this goes on all the way to infinity. Let's look at B. 3x minus 2 is greater than or equal to 0. 3x is greater than or equal to 2. We add 2 on both sides. Then I want x by itself, so I divide by 3. X is greater than or equal to 2 over 3. Now my interval notation would be 2 over 3, comma, infinity, which is not included because it goes on and on and on. The last one that we have is 8 minus 2x greater than or equal to 0. Now I want a minus 8 on both sides. This is cancelled. I'm left with minus 2x is greater than or equal to minus 8. I want to divide by negative 2, and remember inequalities, when you divide by a negative number, we have to switch the equal sign. This becomes a positive 4. So my integral notation would be negative infinity to positive 4 included. So again, remember this is negative 2x because I'm bringing this down. Our last example for today's lesson is consider the function f of x is equal to the square root of x squared plus 4x minus 12. Using a calculator, I want you to sketch this on the axis provided. So I will wait for you to get a calculator and go try to sketch this. Remember, sketching and being accurate, I understand it's difficult for you to sketch and you don't like graphing, but this is how it comes on the Regents, guys. You have to practice, practice, practice. So get your calculator and I want you to sketch this. Pause this video, go get your calculator. Thank you. Alrighty, you should have something that looks like this. Alrighty, it starts here at positive 2 and then here at negative 6. So the last part says set up and solve the quadratic inequalities to yield the domain. So we know these are where it crosses the y-axis. So our function up here, this is a quadratic. Remember what we do to get the domain. Take that what's under the radical sign and you make it greater than or equal to 0. Remember, this is my x where I have negative 12 on the top, 4 in the bottom. We know this will be a positive 6 and a negative 2. So this is actually x plus 6, and x minus 2 would have to be equal to 0 if I was to solve this quadratic. I know I have this sign here and I put an equal sign there. It's okay. So when is x equal to 0 in this case? So we have two options. X plus 6 equals to 0, or x minus 2 is equal to 0. This would be x is equal to minus 6 and x would be equal to positive 2. So these are my two choices where it relates to these 2 points right here. Now, how do I get the domain? So for the domain, what we need to do is that we need to pick some points that are between this, because I know x is going to be at negative 6 and x is going to be at positive 2. So I have to write a set builder, and I want to pick a number. I would always suggest start by picking a number between these two. The easiest number that's between negative 6 and positive 2 is 0. So using my equation up here, when x is 0, what is the value? So I'm going to choose x to be 0. And I'm going to see wherever I see x, I'm going to replace it with 0. So instead of x squared, it will be 0 squared plus 4 times 0 minus 12. Oops. If I was to work this out, I would get the square root of negative 12, which we know does not exist. So what that means now to write a set builder is that our domain is x such that x is less than or equal to negative 6, or x is greater than or equal to 2, because we picked 0, which was in the middle, and that did not work out. So anything that's between negative 6 to positive 2 will give you a do not exist or an error undefined. So that's why it has to be all the values that are less than or equal to negative 6 and all the values that are greater than or equal to positive 2. Alrighty guys, that's our lesson for today. Go ahead and do your practice problems. Good luck!